If you've ever seen one of these big-headed TVs, then chances are your kid is old enough to run errands for soy sauce by now. What's really inside that big head? And how exactly does it display an image? This was one of the biggest unsolved mysteries of my childhood. Today, let's finally figure it out together. This kind of big-headed TV that holds memories for generations is actually called a picture tube TV. The picture tube is also known as a cathode ray tube, or CRT for short. It's the core component of the TV. That big, heavy part in the back that looks like a huge head. Besides that, there's also the circuit board and speaker. When a TV signal comes in, it first goes to the motherboard. Then the control unit splits the signal into audio and video parts. The audio signal goes to the audio unit, while the video signal is sent to the video unit. The audio unit's job is to turn electrical signals into sound. Pretty easy to understand. Let's focus on how the video unit uses the CRT to display video. Cathode rays were discovered by a British physicist. In 1879, they use a vacuum tube, with one end connected to the negative terminal, and the other to the positive terminal. Voltage causes the negative end to emit rays toward the positive end. These are called cathode rays. The rays are made of electrons. If you place a magnet in their path, the rays will change direction, which means we can control their movement. That's the principle behind how CRT TVs work. The big-headed picture tube is actually a vacuum tube. At the very back of the TV is an electron gun that fires high-speed electron beams. The electrons eventually hit the screen, which is coated with a fluorescent material that lights up when struck by the electron beam. To control the direction of the beam, the middle and back of the tube are surrounded by deflection coils, electromagnets that guide the electron beam. But the beam doesn't light up the entire screen all at once. Instead, it scans the screen line by line, either progressively or interlaced very quickly. One electromagnet controls the beam's horizontal motion, and another controls the vertical motion. By adjusting the current, we can make the beam hit precise spots on the fluorescent screen. And by controlling the intensity of the electron gun's output, we can adjust the brightness of each spot. The scanning happens incredibly fast, 50 to 60 times per second, so the human eye sees it as smooth, continuous motion. But at this point, it can only display black and white images. So early picture tube TVs were all black and white. Color TVs were much more complex to invent. So it wasn't until more than 20 years after black and white TVs became widespread that color TVs were finally invented. Now the technology doesn't seem so complicated. We all know that every color we see is made from a mix of red, green, and blue. So engineers started by precisely arranging red, green, and blue fluorescent dots at each pixel on the TV screen, making sure every pixel had all three colors. Then they added 2 more electron guns, making a total of 3, each one firing electrons corresponding to red, green, or blue. To make sure each beam only hits its matching color dot, a component called a shadow mask was added. It's a metal sheet with thousands of tiny holes, each one lined up with a pixel on the screen. Because the electron guns are positioned differently, each beam can only hit its designated color dot. Thanks to this setup, the TV can precisely control the color of each pixel without mixing them up. By adjusting the strength of the red, green, and blue beams, the TV can mix different colors. And by precisely controlling the output of each electron gun, it can adjust the brightness of each color to produce the exact shade needed. That's how a color CRT TV creates its color display. Have you ever seen one of these TVs?